Show Me the Science with Professor Luke O'Neill.
Hello, I'm Luke O'Neill and welcome to my Show Me the Science podcast. Now, here's one for you, the science of sweat. You might be saying, what is he talking about this week? Well, this is a book I came across by a writer called Sarah Everts, and it's all about sweat. And I knew a bit about sweat myself as a biochemist, because we all sweat. And it's a really interesting thing to think about. But this is some fascinating stuff about sweat coming out all the time. Yet another bodily fluid. I think we've discussed other ones. We may go through them all one by one, but sweat is a very vivid one because everybody sweats, as you all know, at different times, and exercise makes you sweat and all kinds of things. And science wonders, why do we sweat? What's the function of sweat? How important is it? Probably more importantly, if you're practically minded, is the whole industry of deodorants.
Roll the roll on, all sticky and wet. Or spray your underarm. What a fog you'll get. So give me the stick, Old Spice deodorant stick. It goes right to the spot. All wet or foggy it's not. It guards against odor the whole day long. With Old Spice freshness, you cannot go wrong.
Now, guess how big the market for deodorants is. We must be a very smelly species because it's $75 billion a year in the world is spent on deodorants. Isn't that ridiculous? Those little roll-ons and sprays and everything. Huge industry because nobody wants to be smelly. I suppose it's a bit of an unfortunate thing socially if you're smelling a bit. So it's huge, right? And then the other thing that's interesting about this is many cultures celebrate sweat. Now, what do I mean by celebrate? Well, if I go to hammams in the Middle East, you go in there and you sweat buckets. The Native Americans built sweat lodges, which of course when Europeans arrived they spotted the Native Americans going into these sweat lodges. And then of course in Scandinavia saunas were invented to go in and sweat buckets as well, and the Finns get the credit for inventing saunas. So it seems to be something important to us. We like to sweat, and obviously some of those places that where people sweat a lot, was it good for your health? And there is evidence actually that sauna is actually very good for you. So there's a lot of stuff going on culturally, biochemically, and in terms of smelliness, the world of sweat. Now, what's it for? I mean, it's obvious. Get ready. Obviously, we sweat when we overheat. So it's a way to dissipate heat. Being alive is to sweat, as Sarah says in her book, and it's a great phrase, isn't it? So we all sweat because we get hot, don't we? And it's amazing how much heat our bodies can produce over time. When you're resting, this is really fascinating, just no exercise, you're generating enough heat to light a 60-watt light bulb. If you could capture the heat coming off your body somehow, you could light up a little light bulb, and that just shows you how much heat that we're releasing all the time. And it looks as if our what's called our basal metabolism, which means how we digest food, I suppose, mainly. But also we generate heat in that process. And of course, we're generating heat to keep our body temperature up. We're warm-blooded animals. Body temperature's kept up as well, obviously enough. And that's coming off the heat that we're generating in various ways. So we're hot, us creatures. Some of us are more hot than others. Owen is a very hot guy. He's often sweating here. But we're hot and we generate heat. Now, because the heat will build up, we have to be able to dissipate that heat somehow. Otherwise, a thing called heat stroke can happen, and we've seen this. And before we discuss this, I guess if you overheat, it's a bad thing. You can get organ failure and all kinds of things. So we evolved a way to dissipate heat, and we do it through sweat. And many animals do this, actually. They generate a bit of sweat to dissipate, but it's unusual. Primates are especially sort of prone to generating sweat to dissipate heat. Elephants use their ears to dissipate heat. Dogs, of course, pant, and we all know dogs, and they're panting away. That again is to cool them down in various ways. But we mainly use sweat to burn off some of this heat, I guess. And even stuff on evolution is interesting. We couldn't have evolved the capacity to hunt, say, because obviously we take exercise as we hunt, and we would have overheated. So it looks like as if sweating allows us to do things like hunt, for example. And as I said, it does seem to be somewhat uniquely human, at least to primates, that we sweat an awful lot. So our ancestors, I guess, through history evolved this mechanism, and it's quite complicated. There are special glands called eccrine glands in your skin. Your body is covered in them. And these eccrine glands, they gather fluid from blood. Blood is the source of the liquid that comes out. And obviously then this salty water, effectively is what it is released through these eccrine glands. And it can happen and you wouldn't even notice it. If you're in a very dry climate, you don't even notice the sweat building up on your skin. Obviously, if the air is very humid, you see some of this liquid build up, and we can see the sweat droplets then coming off our skin. And again, that is a way to dissipate the heat in our bodies. Now, what's very good is, as a biochemist, and I would have actually, strangely enough, known people to analyse the content of sweat from a biochemical point of view. It is very salty, but that just reflects your blood. Your blood is salty already, and some of those salts get into the sweat fluid, and then salt, as a result, is salty. But it's also full of many other chemicals. And it can contain fatty-like substances to help lubricate the skin, for example, is one part of sweat as well. And then guess what? What we eat can come out in our sweat. And they've shown this in very clever experiments. So if you drink loads of cranberry juice, someone did this, you'll notice the sweat is a little bit red. The natural red pigment in cranberry juice will eventually end up in your sweat, and that was noticed. Caffeine is very easy to detect in sweat. So again, if you have a cup of coffee, eventually some of that caffeine goes into your circulation and ends up getting into your sweat. So it's like a constant, I suppose. There's a production of fluid from your blood the whole time, and some of the stuff that's in your blood then ends up in your sweat. And a great experiment was done by a German scientist, Michael Zeck. He wondered how quick would it be from when he drinks something, some of the stuff in the drink ending up in his sweat. Now, again, you wonder why he bothered doing that, but it's still an interesting experiment to do. And he drank a thing called Weizen, which any German person who's listening will know. That's a wheat beer cola combination that's drunk in Germany. And he tried to detect then some of the chemicals in the Weizen in his sweat. And guess what? Within 15 minutes of him taking a drink, some of the stuff in the Weizen ended up in his sweat. And that just shows it's a rapid process. So you drink something, goes into your stomach, obviously, gets absorbed. Some of the stuff ends up in your blood. The nutrients would be in your blood anyway to go around your body. And then you're pumping out liquid the whole time from your blood into sweat. So 15 minutes, it's amazing. Struck me as quite a short time to go from drinking something to the chemical that you drank or whatever, the stuff in the drink to ending up in your sweat. So it's very interesting. And therefore, you can take a sample of sweat, measure things in it. And of course, this is used to see if someone's been taking drugs, for instance. You can measure drug use through sweat as well. And that can become forensically important, as I'll explain too. And then the other thing that is a real fascination in many ways is when we produce too much sweat. Now, we can produce sweat from exercise. Equally, when you're stressed, you're inclined to be a bit sweaty. Now, why is that? Well, adrenaline gets you to make more sweat. And the big question is, why is that? A stress response, and you make adrenaline, maybe you're getting ready to take exercise, the flight and fight response, and therefore you want the body to stay cool because you're going to be exerting yourself. So maybe the reason why we sweat when we're stressed is to anticipate exercise or running or fighting and keeping our body cool. So that sweat response to stress then may be tied into that, which is very interesting in terms of why we sweat much more. And then another big one, of course, is, and this is the slightly, I'd say, not great science, but it's not bad, is we pump into our sweat pheromones. Now, pheromones are the way we attract the opposite sex or try to attract a partner through pheromones, and many animals and insects release pheromones. And it was always a bit controversial. Did humans release pheromones? Lots of studies now suggest that indeed we do. And you release these chemicals into your sweat that will attract, you'll then be attractive basically. And they try to characterize these in various ways. One is called androstenone and androstenol. They're coming off testosterone, so male sweat can be somewhat attractive, of course. And remember, the reason why sweat is smelly is because of bacteria growing there. Natural sweat doesn't smell nasty at all. If anything, it can be very pleasant and can be a way to attract a mate. So the whole area of pheromones going into sweat has been a really interesting area for many to study. And where that came from was the T-shirt test. And I bet you're wondering, what the hell is the T-shirt test? Well, they got people to wear T-shirts and then got people to smell them and got people to evaluate them. And it's a really interesting thing because it turns out that when a man sniffed a woman's T-shirt, if she was ovulating, he rated the sweat as smelling a bit more pleasant. Now think about that for a minute. It looks as if during ovulation, when the woman is fertile, she's releasing a pheromone into her sweat to be attractive in terms of smell to a mate, and then maybe her egg will be fertilized. We're very biological machines, of course, and that was one example of a pheromone. And that study seems to have held up. It's something that may well be true. Now, when women sniff a man's T-shirt, this got interesting as well. And it turns out that if the woman sniffed a T-shirt and it smelled nice, right to the woman's nose, the man was inclined to have a more symmetrical face. Now, isn't that ridiculous? Not sure I believe that study, but still it's been published. So in other words, that meant he'd good genes because he was symmetrical. Symmetry means strong genes, I guess is one way to look at it. And lo and behold, his sweat then was smelling nicer for the woman, and she'd be drawn to the more symmetrical man, and then would get him in a way to fertilise her egg, and then we get a symmetrical baby, that kind of thing. So in other words, there is some evidence that we can sniff pheromones in sweat, and that might be another function for why we're putting things into sweat and why it smells in a certain way. The other one that was interesting was from my own area, and I'm an immunologist, I guess, as people might know. If you're infected, the smell tastes really awful. And that's been shown experimentally. And there's something going into your sweat when your body has bacteria on board that makes you smell a bit. Now, the reason for that is stay away, and remember, as we all well know with COVID social distancing, this evolved, it looks like, that if you were infected, you might repel people basically, and then they won't get infected. And that seems to make biological sense. And they're very interested in this, obviously, for all kinds of reasons. Could you use sweat then to detect if someone's infected? As a diagnostic, you never know. But certainly, when you're infected, you start to smell a bit unpleasantly, and then people will be avoiding you and they won't pick up the infection. So it's very clever, that, in a way, in terms of evolution. And then the last part, before I get into some of the more forensic parts, which are interesting, is tears. Now, we're not going to do the science of tears. I couldn't fill 12-15 minutes just about tears, although you never know. Tears are interesting as well. And here's a study where they got people to smell tears, right? Why do you hear this? So, and they got tears from people who were watching a sad movie, okay? This, again, maybe slightly dodgy science, but anyway, they watched a sad movie, they started to cry. And if a man smelt those tears, it made him feel sad as well. Isn't that nice? So in other words, he built up empathy by smelling tears from someone, and obviously that person was sad, and then the man might help them. So that's another legitimate study that was done. So tears also have a smell, a bit like sweat, I suppose. There's something in the tears. Now, the other thing that's really interesting that could be very useful is forensics. So obviously you can detect things in sweat anyway, and that might be a drug, say, for instance. You can take samples of fingerprints. So when you leave a fingerprint on a surface, that will have residues of the sweat coming off your fingers. And again, they've used this forensically. And one very interesting study that Sarah Everts mentions is they get fingerprints off a guy who had assaulted a woman, and they measure the chemicals in the fingerprints, and they detected a thing called cocoethylene in the fingerprint. Now, cocoethylene is a most unusual chemical. It's only made if someone has taken cocaine and alcohol. And those two react and produce cocoethylene. And sure enough, this guy was shown, part of the evidence to arrest him was he'd taken cocaine and alcohol, and that it ended up in his sweat. And that was part of the evidence that was used in that trial against him. He was arrested because he'd been in stalking this woman, and then they could get more and more evidence against him, if you like. It just shows you. So they're using sweat now forensically to try to measure these sorts of things and then get evidence. And then one other thing that it's being used for as well is they're measuring things called amino acids in sweat. And that's another chemical coming off proteins. And this can measure level of fatigue, which is very interesting, right? And again, this is something that could be useful. A bit like forensics, I suppose. You can use these things in a way that could be useful. And the higher the amino acids in the sweat, the more fatigued you are. Now, why would that matter? Well, it might matter for pilots, say they're talking about this, to have a sensor for pilots in airplanes. If they're getting fatigued, the amino acids go. Or maybe drivers, if you're driving a car and you have a way to detect amino acids in sweat, maybe it's time to stop driving if you're fatigued. And this is literally what they're developing, which is really, really interesting, it must be said. Now, lastly then, let's go back to where I started with deodorants and all that kind of thing. Can you believe it? I'll say it again, $75 billion worth of deodorants are selling every year. Huge industry. Now, there's two things going on there. One is to not make you smell as bad, but secondly, antiperspirants. Can you stop sweating, basically, which could be useful in certain situations. The less you sweat, the less bacteria grow, the less smelly you are. But sadly, some people sweat more than others. There's a huge range of the level of sweat, and it can be very awkward for some people if they're sweating buckets the whole time. So antiperspirants can be very useful for those people. And where did these deodorants come from? Well, the ancient Egyptians knew about it inevitably. They used to use lilies. Frankincense, famous for the three wise men, that was often used as a deodorant as well. But the very first deodorant to be made was 1888, and it was called Mum. Now, why do they call it Mum? I don't know. But that was the very first deodorant. It had zinc oxide. So chemists began to realise certain chemicals would deodorise sweat or indeed stop perspiration, and zinc oxide was the first one. Aluminium-based chemicals, aluminium chloride, can also work. They're mainly killing bacteria, so therefore, you don't smell quite so much because the bacteria are being killed by these things is one thing. And the next thing was they began selling these, and people didn't really buy them. You had to paste them on under your arms, say, with a little brush. That was hopeless. Finally, in the 50s, the big breakthrough: roll-on deodorant.
So, Kathy, why go to school with a dry blouse and a false sense of security? Tomorrow, use your roll-on and be just as sure about odor as you are about wetness.
Now that revolutionises the world of deodorant. So you could roll it on, couldn't you, instead of having to dab it on yourself? And that's what's, people often have roll-ons now. And then in the 70s, of course, aerosols are used to spray the stuff on, and that has a big effect as well. And sales go through the roof. As soon as they devised the roll-on deodorant, then that became much more convenient, and people began to use them more and more. So, in other words, we can get rid of smells in our sweat. Of course we can, with these deodorants and these antiperspirants. But remember, sweating is a healthy thing. It keeps us cool. It regulates our body temperature and maybe exudes a pheromone to attract someone if you're that way inclined. So remember, try not to be taking too much deodorant, too much antiperspirant. It's a natural thing. Regular washing is useful. You don't want to be too smelly either, do you? Let's face it. So always remember, try and stay as clean as you can. And if you've learned anything from this particular podcast, is sweat remains absolutely fascinating. Who knows what's going to happen next in the science of sweat? So thanks for listening, and my podcast is available for download every Thursday, and it's a News Talk production, and all the very best.